this is quick revision of chapter number 3 of Statistics 1 at Excel IAL. Come on, Mahad, explain me what is histogram.
Okay, so a histogram is a graph that displays grouped continuous data.
Hmm.
On the y-axis, we have the frequency density, and on the x-axis, we have the x values.
Okay, come on, tell
And
me
then,
something. If you have the group continuous data, your class intervals should can be different or they always need to be the same.
no, it can be plotted for unequal class intervals.
And should there be gaps between the data or the data should be continuous?
It should be continuous.
Okay. So and you have height and frequency. So where is frequency recorded?
Frequency is basically the area. Frequency is proportional to the area.
Okay. Okay.
So we do not directly record the frequency, instead we record the frequency density.
How do you get frequency density?
Frequency density is equal to frequency divided by class width.
Okay, fine. Go ahead. Then
Yeah.
frequency
Area of the
area.
bar is
Hmm.
area of the bar represents the frequency.
Okay.
This relationship is expressed as area of the bar equal K into frequency, which basically means area is directly proportional to the frequency.
So you write
And
area is proportional
when,
to frequency and then you write A is equal to KF.
yeah,
Okay.
and when K is equal to 1, the
Hmm.
frequency density equals the frequency divided by the class width. So basically, the frequency density is equal to the frequency.
Okay. This will be equal to the frequency.
Yes,
Okay. When K is equal to 1, you said frequency density will be equal to frequency.
my bad, my bad.
Hmm?
Frequency divided by class width.
Okay, fine. So this is all about the histograms. And if you want to plot an histogram polygon, frequency polygon, you just take the midpoints and plot it. Am I correct? Haris, outliers. Now the next topic, outliers.
Yes. So for outliers, the first thing you need to calculate is your Q1 and your
What is
Q3.
outlier? But
Okay, outliers are extreme values in a data.
okay,
Okay, and they could be mistakes, but they could also be correct values. We're not very sure of that, but normally it's a mistake. Okay,
can you explain
and
this in detail? What is this? Normally, it is a mistake.
there could be a mistake. The data which is extreme value could be a mistake or could be reasonable data. So, as an example, on a birthday party of children of 7 years old, there's multiple 7 and 8 and 9 years old people, but there's someone of age 40, let's say, attending the birthday party. That could be a parent, therefore he's there. Okay.
Okay.
So it
What
could
is,
be correct, but then it could also be wrong that someone entered wrong values.
so give me an example where there is mistake in the data.
So a mistake would be that they were trying to enter the value 4 and they put a 0 instead. So that would make it 40.
Okay, fine. So outliers have a effect on statistical measures. What are statistical measures?
Statistical measures are mean, median, mode, IQR, and stuff like that.
Okay, so outliers, because of outliers, what are the things that gets affected?
Because of outliers, mean and range are affected. Since mean are affected by extreme values and range is affected by extreme values as well.
Okay, how do you find the outlier?
Okay, so for outlier, there's two kinds of outliers. One which exceeds the upper bound, and one that is lower than the lower bound.
Okay.
Okay. So to calculate the lower bound, you have to do Q1 minus the outlier threshold multiplier. The outlier threshold multiplier is normally 1.5 into IQR,
How
but
does
it could
IQR calculated?
IQR is calculated by Q3 minus Q1.
Okay.
Okay. And again, the outlier threshold multiplier is normally 1.5 into IQR, but some questions might also tell you what the outlier threshold multiplier is. So you have to add or minus it from the Q1 and Q3, and you get your lower bound, upper bound, and you recognize your values above it and lower it to get your outliers.
Okay. Can you explain me what is this as well? And where will the outlier lie?
So the line in the middle of the box is the median. You just want me to tell you where the
Hmm.
outlier will
No,
be?
explain me this box and tell me where will the outlier.
Okay. And the line that starts the box is going to be the lower quartile.
This is the okay. This is the lower quarter.
Yeah. Okay. And the line that ends the box is the upper quartile.
Hmm.
Okay. And the whiskers, where they end and where they start, are the maximum and minimum values the data can have.
Okay. Where will
Okay.
the outlier lie?
Outlier will lie outside of the whiskers.
Okay. Very good. So this portion is what?
This portion is 25% of the data.
What is it called? Lower 25 is called what?
Lower 25,
It's called what?
Q1.
Q1,
This portion is,
Q3.
and this,
This is the IQR, so this is 50% of the data.
it is 50% of the data. Very good. Okay. So we finished revising outliers and box plot.
Yes.
So we had first histograms. We discussed what is histograms and we discussed outliers. Okay. In outliers, the main thing is that you have to find the OTM, outlier threshold multiplier, calculate the lower bound, upper bound, and then clearly define your outlier. And sometimes they ask you whether it is an error or it is a valid data. So you have to see in the context of the question and try to explain it. Now the next topic is stem and leaf diagram. Mahad will explain it.
Yes.
Hmm.
Okay, so a stem and leaf diagram shows raw data, and
Hmm.
groups the data into class intervals. Basically,
Means what?
on the left side, you have what?
Hmm.
On the left side, you have the stem,
Hmm.
and on the right side, you have the leaves,
Okay.
which basically, and then there's a key.
Hmm.
The key shows how the stem and leaf tree diagram is supposed to be represented as.
Okay.
So in this example, the key is 08 is equal to 8 minutes.
Okay.
So that means if
Another
the
way to
key
write this
is
key.
what?
Is there any other way to write this key?
Yeah,
What
it
if the
could
key
be.
was zero
I mean,
0.8
we can,
and this was 0.8?
yeah,
What does this mean?
this means that there's 0.8 minutes,
So if it was 1, 2, then it will become for this
1.2
key
minutes,
1.2. And for this key, it would become
12.
12 minutes. Okay, very good. Continue.
It's simple as that. It's done.
How would you classify the stem and leaf? Can you have more than one stem? That means more than one digit in your stem.
Yes.
Okay, and in your leaf?
A leaf, it's only supposed to be one digit.
Okay, fine. So they are always a single digit and stem can be more than one. Okay,
Yeah.
what else?
What else?
So there
Okay,
is
yeah.
this,
One
what is
stem,
back-to-back stem leaf diagram?
yeah. A back stem and leaf diagram is basically one stem for two data sets.
Okay.
So there's going to be one key here
Hmm.
which says key 601, and the
Hmm.
middle one is basically the stem, so it's going to be first and then the leaf. So 60 is supposed to be 0.6 meters
Sure.
and 01 is 0.1 meters.
So 0.6 is for what and 0.1 is for what?
0.6 meters is for the length of wild snakes,
Okay.
and 0.1 is for the length of pet snakes.
So for a back-to-back stem and leaf diagram, you have 0.6 and 0.1. Yeah?
Yeah.
Okay. So
Mm.
you can have two keys like this.
Yeah.
Why do you use a stem and leaf diagram?
We use it to organize our data.
Okay. What else can this show?
This can help us find out the model class interval, skewness, outliers,
How?
or you, what
How?
the model class interval will be the one with the highest number of leaves
Repeat.
repeated. Yeah.
Okay.
And then skewness,
How can they show the minimum value and the maximum value? Like over
the
here.
minimum value, the minimum value will always be the first value, which in
Hmm.
this case is 0.8.
Hmm.
So it's going to be 8 minutes. And the maximum value is going to be the last value. In this case, which is 56 minutes.
What does this show?
This shows basically the frequency.
Okay. It is always important to have a title on your stem and leaf diagram, and key is the most important part of the stem and leaf diagram.
Yeah.
Yeah?
Hmm.
Okay. Squeeness, Harris.
Yes. So there's positive skew and negative skew.
What is skewness basically?
Skewness, it tells you how symmetrical your data is.
Okay.
So when it's positively skewed, there's four ways of first there's four ways of recognizing the skewness.
Hmm.
The first one is by visual,
Hmm.
and the visual representation is shown in this example, showing
Hmm.
the positive, negative, and symmetrical skew. The positive skew, you can see it has a peak on the left side, and its tail stretches out to the right side, which shows it's higher in the beginning, but then lower at the end. So more people have higher, less people have
Higher than
less people have higher, and more people have lower. In this case, it could also represent salaries.
hmm.
Okay, that means that many people have lower salaries and less people have high salaries. Um, Negative skew, it shows that less people are what's it called higher, and more people are towards the
Hmm.
higher side, which shows us that more people are doing certain thing. In this case, it could be age of retirement, which
Okay.
is what younger people retire, less younger people retire, and more older people retire. So this could show that. And the third one, which
Many
is,
people retire at a higher age.
yeah,
So more data is towards the higher side.
towards the higher side, yeah.
Okay. This is which way of representing squeeness?
This is the visual way of representing students.
So in positive, the tail will be towards the
Right side.
Okay.
Negative, it will be on the left side.
Okay. Then.
Then the third one, which is the symmetrical skew,
Hmm.
shows that the data is spread symmetrically and there is no skewness.
Okay, fine. This is the first way, visual way. Positive
Yes.
skewness, tail is on the right, negative tail is on the left, and for symmetric, there is no skewness. Okay, second way.
Okay, the second way is the formula of Pearson's skewness Pearson's formula, which is 3 times mean minus median divided by standard deviation. So if the answer you get from this is less than zero, more than zero, it's a positive skew. If it is less than zero, it's a negative skew. And if it is zero, that means it's a symmetrical distribution of data.
Okay.
Okay. Then the third way of recognizing skewness is the comparison of mean, median, and mode.
Okay.
So if it's symmetrically distributed, mean equals median and median equals mode.
Okay.
Okay. But if it's a positive skew, mean is greater than median, greater than mode.
Okay. Which two data will you take to decide?
Uh, to decide positive skew or negative skew,
Yeah.
mean and median.
Okay. So if mean is more than the median,
It's positive skew.
and if mean is less than the median, then negative skew.
Yeah.
Okay. Can you summarize these three in a more shorter way?
Miss, there is a fourth way as well.
Okay.
Okay, the fourth way is through the box and whisker plot.
Hmm.
Okay, which is if it's a symmetrical skew, Q2 minus Q1 is equal to Q3 minus Q2.
Hmm.
Okay, but if it's a positive skew, Q2 minus Q1 is less than Q3 minus Q2, which shows that the median is closer to the lower quartile.
Okay.
And the negative skew, Q2 minus Q1, is greater than Q3 minus Q2, which means the median is further away from the lower quartile, showing it's negatively skewed.
Hmm. If median is closer to the lower quartile, positive,
Yes.
and closer to the upper quartile, then negative.
Yeah.
Okay. There is another way also, na, when you look at the.
When you look at the box and whisker plot,
Hmm.
so you can see that the whisker, if it's symmetrically distributed, as in the both sides are of equal length,
Hmm.
which means it's symmetrically distributed. But if the left side of the whisker is lesser in length than the right side, it's positively skewed. And if the left side is greater in length than the left side whisker, which means it's negatively skewed.
Okay. So if left side whisker is small,
If left side whisker is more, which means it's gonna be negatively skewed.
if it's small, it's positive, and if it's more, it's negative.
Yes.
Okay, fine. Can you give examples of this salaries in UK?
Salaries in UK. So when the salaries are higher in the UK, which means that the mean is gonna increase.
Already more people have less salaries.
Yeah, more people have less salaries, but
Then,
I'm using the way of finding the skewness, which is mean greater than median. I was gonna tell in that way.
okay, but normally we have to decide this with logic.
Yeah, this could be also logically said because more salaries. are lesser paying than,
Which
you
skew?
know, this is positively skewed since less people are getting paid higher.
IQ,
IQ, there is no skew.
height,
No skew. Age of retirement is negatively skewed since more older people tend to retire than younger people.
okay, fine. So this is all about skewness. Come on, tell me over here. Answer this question.
This question, since
This is closer to.
the since the median is closer to Q1, which means it's positively skewed, and
Mm,
since in the second one the median is closer to Q3, it's negatively skewed. Okay, and since in the third example it looks like it's symmetrically placed, that means there is no skew.
okay, I'm giving you 2 minutes time. Write all the four ways of whatever you remember.
Okay.